All right, ladies and gentlemen, we are talking about solving systems of equations using the equal values method. This is one of 4 ways to solve a system of equations. The other methods are graphing, where you can graph the 2 lines and look for the intersection, and the other 2 are substitution method and elimination method. Look to those videos to learn more about them, but this one looks at the equal values method. The equal values method is based off of one algebraic property, and that is the transitive property of equality. The transitive property of equality, I gave an example in class about kids scoring the same number of home runs or getting the same amount of candy at Halloween. And we said if Bobby got the same amount as Jimmy, and Jimmy got the same amount as Dave, and if we know Bobby got 5 pieces of candy at one house, well, then what did Dave get? And we said, well, if Bobby got 5, they all got 5 because they're all equal. Well, that's what it says because it mathematically just states if A equals B, and if A also equals C, well, then we must conclude that B is equal to C. All right, that's the transitive property of equality. Now, how does equal values method apply that? Well, when we look at an equation such as y equals 3x plus 5 and y equals x plus 19, we're looking for the value of x and y that's the same in both equations here. The one point that will make both equations true. It's a solution to both equations. That's why it's the solution to the system of equations. So in this case, if 3x plus 5 is equal to y and x plus 19 is also equal to y, well, then 3x plus 5 must equal x plus 19. That's the transitive property of equality. Doing this now gives us one equation with only one variable x, and we can draw our line down the center to solve. Subtracting x from each side in order to get my x's over to one side altogether, and then subtracting 5, that is supposed to be a 5, not a 6, 5, all right, from each side in order to get my x term completely alone, at which point I will then divide by 2 to get my x as 7. So now I know that x is equal to 7. Most students will make the mistake of stopping there. That's not where we stop. A system of equations is looking for both x and y. So I can take this x value and I can go back to either one of my original equations here and I can plug it in. I'm just going to choose my first equation, y equals 3x plus 5. And I'm going to plug x into that. So I'm going to say y equals 3 instead of x. I'm going to put 7 because that's the value of x that I found that makes both equations true here. And when I do that, 3 times 7 is 21, plus 5 is 26. And I see y is equal to 26. Assuming that that is correct, it should work in both equations. Therefore, if I used my first equation to find y, I must use my second equation to check my answer. As I do my check step, I want to make sure that it works in this equation as well. So I said y equals x plus 19 is my second equation. I said y was 26. I said x was 7. And I double check. Indeed, 26 does equal 26, which works. Therefore, my answer is correct. How do I write it? Well, we're looking for the one point that makes both equations true. So we want to write this as an ordered pair. We will always write it in the form of x comma y in parentheses. In this case, x is 7 and y is 26. So my point of intersection for these 2 lines is 7, 26.